Are you feeding your body or feeding your disease? Now, what if skipping meals didn't weaken you, but transformed you into a fat-burning machine? Could your body's garage sale of damaged cells be the secret to longevity? Are you fueling disease with constant snacking or sparking renewal with strategic pauses? What happens when you starve yourself of food, but feed yourself on energy reserves? Welcome to the world of fasting, where science meets spirituality. You might have heard people talking about intermittent fasting or religious folks observing fasts. But did you know that fasting could also transform your body? We'll explore the stages of fasting, what happens to your blood sugar, and what exactly this practice entails. So let's delve deeper. What is fasting? Fasting is the deliberate avoidance of caloric intake for a specified window. Beyond simply skipping meals, it's a metabolic reset that shifts you from storing energy to mobilizing it, igniting hormonal, cellular, and genetic adaptations that support health and resilience. Main types of fasting modalities. There are primarily 3 types of fasting. Intermittent fasting. This involves cycling between periods of eating and fasting. Common methods include time-restricted eating windows such as 16/8, 18/6, or 1 meal a day OMAD. Alternate day fasting, where calories are restricted every other day, or the 5-2 method involving 2 low-calorie days weekly. Number 2, prolonged fasting. These are continuous fasts, lasting 24 to 72 plus hours. In yogic traditions, we follow Ekadashi-style fasts, Lent abstaining completely or partially for 24 hours, roughly every 15 days. Now that we've grasped the basics, let's embark on a fascinating journey through the stages of fasting. We'll delve into what occurs within your body during various fasting durations. There are 4 types of stage in fasting: anabolic phase 904HR, catabolic phase, gluconeogenesis, 12 to 48 hours, ketosis, phase 48 plus hours. Finally, deep ketosis and autophagy, 48 hours. Stage 1, anabolic phase, 0 to 4 hours. Imagine you just enjoyed a delicious meal. Your blood glucose levels rise as your body breaks down carbohydrates into usable energy. Insulin takes center stage, shuttling nutrients into your cells and promoting glycogen synthesis in your muscles and liver. In this phase, the body is focused on digestion and absorption of nutrients from the most recent meal. Protein synthesis is maximized, supporting tissue repair and growth. Stage 2, catabolic phase 4, 1-2 hours. In this stage, insulin levels begin to decline, while glucagon and growth hormones start to rise. This signals your liver to kick into gear, breaking down stored glycogen into glucose through a process called glycogenolysis. This keeps your blood glucose levels steady between 80 to 100 milligrams DL. Growth hormone also starts to tick upward, supporting the preservation of lean muscle mass. Initially, lipolysis comes into play with fat cells releasing free fatty acids into the bloodstream as an alternative energy source. Stage 3, gluconeogenesis, phase 12 to 48 hours. As glycogen stores start to deplete, the gluconeogenic machinery in your liver and kidneys springs into action. They produce new glucose from amino acids, lactate, glycerol, and other available substrates. Despite this, muscle protein breakdown remains minimal thanks to the rising growth hormone. Cortisol levels increase modestly, contributing to sugar production and helping you stay awake and alert. Notably, cellular stress resistance genes like FOXO and sirtuins begin to activate, enhancing your cell's resilience. Stage 4, ketosis phase 48 plus hours. As the fasting period extends, ketone bodies like beta-hydroxybutyrate and acetoacetate start appearing in your blood. After around 24 hours, your brain, which normally relies on glucose, begins shifting to ketones for energy, utilizing about 30% of its fuel from this source. Your muscles adapt similarly. During this phase, autophagy accelerates. Damaged mitochondria and misfolded proteins are broken down and recycled, promoting cellular renewal. Signals for mitochondrial biogenesis intensify, boosting the production of energy-efficient mitochondria. Stage 5, deep ketosis and autophagy, greater than 48 hours. With prolonged fasting, ketones can supply up to 60 to 70% of your brain's energy needs. Autophagic flux reaches its peak, enhancing the cellular cleanup process and balancing your immune system. Inflammatory markers like TNF-alpha and IL-6 decline, while antioxidant defenses rise. Additionally, epigenetic modifications come into play, promoting longevity pathways and metabolic flexibility. What happens to your blood sugar during fasting? Your body orchestrates a remarkable balancing act to maintain stable blood sugar levels during fasting. Let's break down the mechanisms at play. Glycogenolysis. Your liver stores around 100 to 120 grams of glycogen, enough to sustain blood glucose levels for about 12 to 16 hours through glycogen breakdown. Once glycogenolysis kicks in, your blood sugar rises steadily until the end of the first fasting day. Gluconeogenesis. When glycogen reserves start to deplete, gluconeogenesis steps in. This process converts non-carbohydrate sources like glycerol from fat and amino acids into glucose. Gluconeogenesis is vital, ensuring your body generates the necessary glucose to meet its demands, particularly for the brain and red blood cells. Hormonal coordination. Several hormones play key roles in maintaining blood sugar during fasting. Insulin levels plummet, glucagon rises, cortisol and adrenaline surge, and growth hormone increases subtly. This hormonal dance is crucial for regulating nutrient release and utilization, brain needs. Your brain requires a minimum of roughly 20 grams of glucose per day. Even in deep ketosis, gluconeogenesis ensures that this essential fuel is supplied, preventing hypoglycemia. Renal gluconeogenesis. Your kidneys contribute up to 40% of new glucose. After prolonged fasting through renal gluconeogenesis, this process utilizes substrates like lactate, amino acids, and glycerol to produce glucose, further supporting your body's energy needs. Key takeaways. Our journey through the stages of fasting reveals an extraordinary process of adaptation and resourcefulness. Your body transitions from sugar burning to fat adaptation, activating cellular renewal and demonstrating remarkable precision in blood sugar regulation. Now that we understand the profound impact of fasting on our bodies, let's discuss some key takeaways. Fasting is a multi-phase metabolic journey involving significant physiological changes. It is not merely a period without food, but a dynamic process of adaptation. From the initial post-absorptive state to deep ketosis, your body orchestrates intricate metabolic pathways to ensure sustenance. During fasting, your body experiences dynamic hormonal shifts and metabolic pathway activations. Insulin levels drop, while hormones like glucagon, cortisol, and growth hormone rise. These hormonal changes facilitate the breakdown of glycogen and fats, providing alternative energy sources. Additionally, fasting activates cellular processes such as autophagy and mitochondrial biogenesis, contributing to cellular renewal and energy efficiency. Autophagy and cellular renewal. Autophagy plays a crucial role during fasting, allowing your body to break down and recycle old or damaged cellular components. This process enhances cellular renewal and contributes to the removal of damaged proteins and dysfunctional mitochondria. The activation of autophagy is particularly notable in stage 4 and 5 of fasting, promoting cellular rejuvenation and overall health. Epigenetic modifications. Fasting induces epigenetic modifications that influence gene expression without altering DNA sequence. These modifications can promote longevity pathways and metabolic flexibility, contributing to the potential health benefits of fasting. Blood sugar homeostasis. Your body maintains blood sugar homeostasis during fasting through intricate mechanisms. Initially, glycogenolysis provides glucose by breaking down stored glycogen. As glycogen reserves deplete, glucogenesis takes over, synthesizing new glucose from non-carbohydrate sources. Hormones like glucagon and cortisol play vital roles in this process, ensuring a steady supply of glucose to vital organs, particularly the brain. Potential benefits of prolonged fasting. While more research is warranted, prolonged fasting has been associated with potential benefits. These include reduced inflammation, enhanced immune function, and the promotion of longevity. By entering deeper states of ketosis and significantly boosting autophagy, your body experiences a more profound cellular renewal process. Conclusion: embracing fasting is akin to discovering a hidden superpower within your body. It's not about deprivation, but rather about rewiring your body for resilience, mental clarity, and cellular repair. Each stage of fasting, from the fed state to deep ketosis, is a testament to the incredible adaptability of the human body. By understanding these stages, you gain the power to harness fasting's benefits. Start small, perhaps with a 12-hour fast overnight, then gradually progress to 16 hours, or even consider observing Ekadashi every fortnight. Listen to your body. Adjust as needed and witness the profound transformations that await. Remember, the journey to wellness is deeply personal, and fasting is a tool that can be tailored to fit your unique path. Utilize the amazing benefits of fasting and feel healthier and more alive. Thank you.